This is Geometry's Semester 2 exam review. This is Unit 8. We're working with circles. In this case, we have a radius of 48. We have this total length from C to A to be 80. We're trying to figure out how long this tangent line is. Well, it forms a right triangle, so we can use hypotenuse squared equals leg squared plus leg squared. $80 squared is 64 with two zeros, so 6,400. 48 squared is 2,304. So we're going to take the 64 and subtract the 2,304. And by taking the square root of that, we find out that x is 64. The next problem I have worked out here. I have two tangent lines. They're coming from the same point, touching the same circle. So they're equal in length. So 3x squared minus 10 equals 17. So add the 10 across, divide by the 3, take the square root, and x would have to be a value of 3. For question number 3, we know that PR and QS are diameters. We have some different central angles. We need to find these others. These are measures. So whatever the central angle is, the intercepted arc is going to be the same length. Since this is a diameter, the 3 have to add up to 180. That's 106. On this side, we'd have 180 with that diameter minus the 42. So this is 138. And then here we have vertical angles, two diagonals, two diameters that are intersecting each other form the x, so that's 42. So with those calculations, we should be able to come over and answer most all of these. So the measure of PQ, 42 degrees, ST, 74. TPS, typically that means if it's 3 letters that it's over 180 degrees. So from T to P all the way around to S is the whole circle, not counting the 74. The whole circle, not counting the 74. So we got 286 degrees. RT, 116. RQS is the whole circle. R to Q to S is a whole circle, not counting this 42. So 318. QR, we've already determined, was 38. PQS is 180 plus a little bit extra, or 180 plus a little bit extra. So we got 222 degrees, and TQR is everything but the length of TR, and we learned that TR was 116. So that looks like it's 244. Find the indicated arc measure. We want to know the length of AC. Well, I know that AC and BC, those arcs are the same length. The tick marks help indicate that. If this is 90 degrees, 360 is the whole way around. If we minus the 90, we get 270. Now, if two of them are the same, we're going to divide that by 2 and get 135 degrees apiece. So this is 135 degrees, and so will its arc. We're looking for arc ACB. This circle indicates that they're all three the same. So around here is 360. And if we divide that by 3, we're going to get 120 apiece. Here we're going to find the measure of BC. Well, this arc is 116. These two chords are the same length, which is indicating that these two arcs have to be the same also. So we're going to take 360 minus the 116, and then we're going to divide that by 2, and get 122 degrees. On this side, we're looking for arc BC. Well, here again we have two chords that are the same length. That's telling us that these two arcs are the same. If this is 130, we can figure out what the remaining would be. We got 115 degrees. ST, well, ST is part of the diameter. This is a half the circle. There's the diameter. If you have an inscribed angle, then you know the arc is going to be twice that amount. So this is 122. From 180, we know that this has to be 58. Together they make up 180. we're looking for the angle measure, JLM. Well, JLM is going to be half of arc JM. This is a central angle, which makes it 88. Here's a diameter. So this is going to be 92. And this angle is going to be half of that 92. Which is 46 degrees. Looking for the measure of VST. Typically the three letters should indicate an angle or arc, actually an arc, greater than 180 degrees. That's not true in this case, but we can still find its total measure. Well, it's 360 around the whole thing. If an inscribed angle is 51, then I know that its intercepted arc is twice that amount. So that's 102. 360 is around the whole thing. I can subtract the 135, subtract the 102, subtract the 39, and I'm left with 94. Well, it's not 94, it's 84. So 84 is this remaining amount. But we're looking from V to S to T. And that's going to be 84 plus 39. That should be 123. Typically, three letters would mean an arc that was greater than 180, but in this case, the notation's not best. It should be the measurement of VT, arc VT. Find the value of the variables. Here we have a quadrilateral inscribed inside of a circle. We know that the opposite angles are going to be supplementary. We would also know, because it's a quadrilateral, that all four angles add up to 360. But to solve this, I think we'll just have to use opposite angles or supplementary. So 5x plus 110 has to add up to 180. So we know that x is going to be 4, or 14. And then here we have 2y plus 104. Let's add up to 180. And there y would have to equal 38. These are not degrees. They're just the value of the variable to calculate an angle. On the next page, we're writing equations. Here we have a circle. Remember that the equation of a circle where the h and the k are the center of the circle. In this case, the center is at 0, 0. So we're going to have x squared plus y squared. The radius is 2, 4, 6. So it's 6 squared. So your best answer is x squared plus y squared equals 36. In this case, we see that our center is over 3 and up 1. So we'll get x minus 3, because if the formula is x minus and the h is a 3, then it's x minus a 3. So it looks like x negative 3, but it's really just x minus 3 plus y minus 1. The radius is 2. So we can write our equation of the circle. When we write an equation of a circle, all we need to know is the center and the radius. So if this is the center, which is HK, we're going to get x minus a negative 3 and y minus 0 with a radius of 5. So when the center of the circle moves to the left 3, the equation is going to look like x plus 3. It's always going to be opposite. The center of the circle again, here's our h and k. When you're minusing a negative, it's actually like plussing. So you have your equation. Now we have our center, and we have a point that's on the circle. Let's take a look with a small sketch what that would mean. We're over 2 and up 4. We have another point that is over 3 and up 16. So we have this big circle. We know what the center is. What we don't know is what the radius is. We have another point on the circle, but we still don't know what the radius is. So one way we can do this is to start with our equation. Plug in our x, plug in our h, our y value, and our k value. So essentially it looks a lot like the distance formula. It's the same thing as a distance formula. We're going to subtract our x values, we're going to subtract our y values, and essentially we'll take the square root. So the equation of our circle is x minus a negative 3. No. This is our xy. Be careful not to pull the wrong point. Our center is 2, 4. So x minus a positive 2. Y minus 4. R squared is 169. To graph the equation, need to know what the radius is. If r squared equals 64, then the radius is 8, because 8 squared is 64. The center is at 0, 0. 2, 4, 6, 8. 2, 4, 6, 8. Here we have an HK that is 4, -1. Remember the sign changes. And the radius is 4. To find the circumference, we have two equations we can use for circumference. In this case, they give us the radius, which is half of the circle. So the circumference equals 2 times, or usually you say it as 2 pi r. So we're going to have 9 pi. That would be called your exact answer, because it's not going to have a rounding decimal. If we want a decimal value, we bring over a calculator and we say 9 times pi, and we're going to get 28.27. We'll drop off the ending, so it's an approximated answer. But 9 pi would be considered our exact answer. You got to read your directions. Sometimes they ask for the exact, sometimes they ask for a rounded value. They didn't indicate it here, so I provided both. We're supposed to find the exact radius and diameter of a circle with a circumference of 74 centimeters. We're supposed to know the diameter. So I'll pick the formula that deals with diameter. So here we'll divide by pi. And I'm sure you want to use your calculator. But if you're supposed to have the exact value, then you don't want to have a decimal that you're rounding. The answer here, we're going to call it, is 74 divided by pi. That would be the exact value. You could say that the circumference equals 2 pi r. We're supposed to find the radius. We'll divide by 2 pi. Here we still have the pi in the denominator, but we can reduce with the 2. So 2 goes into 7 3 times. Goes into 14 because you have your remainder 1 7 times. So there's the diameter exact value. Here's the radius exact value. On our final page for the circles for Unit 8, we're supposed to find the length of arc AB. The length of arc AB would indicate this. We're not looking for the measure, which is the degree value, but we're looking for the centimeter length. Here we know that the centimeter of the diameter is 34. We're supposed to find out what the centimeter length of arc AB is. So we're going to say we're looking for the arc length over the circumference equals the central angle over 360. So we don't know what the length of AB is. The circumference is going to be the diameter times pi. So the diameter is 34. We would say that because it's written in the middle of the line. It's not written 34 off to the side like a radius. It's written right in the middle with the dot, with the center point. So circumference equals diameter times pi. The central angle that we're working with is 150. And of course every circle has 360 degrees around it. So here we're going to cross multiply. (34 times pi), and then we'll times that by 150 and divide that by 360. So our arc length is going to be 44.51. And those would be centimeters. Here we'll be looking for the circumference and the radius of the circle. We know that this arc length of ACB is 81.64. So it's the arc length over the circumference, which equals the angle over 360. Here we'll have to cross multiply. We have to cross multiply this direction also. So we have 81.64 times 360 . 260C. We're going to divide by the 260. And we'll get 130.04. That's the circumference all the way around, which would be in inches. Now to find the radius, we know that the circumference is 2 pi r. We have 113.04. To get the r by itself, we're going to divide by 2 pi. So our r value, we're going to divide this by 2 times pi, and we'll get just about 18. 1799, call it 18. That's the exact answer. Well, it's not exact either. The exact answer would be this divided by 2 over pi, but we can say, we'll use our calculator measurement and say 1799 inches. The diameter of a circle is 11 centimeters. Find the area. You need to know what the formula is to find the area of a circle. If the diameter is 11, then the radius is going to be 5.5. So the area is going to be pi times 5.5 squared. 9503. And those are centimeters squared because we're working with area. The area of a circle is 236 square inches. What is the radius? Well, we know that the 236 is the area. What we want to know is what is the radius. So we're going to divide by pi. We know it's not quite an exact answer when we do that. 75.12. Now, instead of starting the problem over and using 75.12, I'm going to take the square root of this full answer. You want to hit the answer on your calculator. In this case, it's the second and the negative sign on your calculator. The negative key has the word A and S written above it. So we're going to figure out that R is 8.67 square inch. No, just inches. It's not squared because that's area. This is a radius, which is a length. It's just inches. We're going to find the area of circle M. Here's M. That's saying that the whole circle is what we're looking for. The area that they're giving us is just this sector. So we have sector area over circle area equals the central angle over 360. Now notice that this side is 161. So if we take our calculator and say 360 is the whole circle minus 161, we're going to get 199 degrees to be on this side. So we have a sector area of 8414. That's the area of our circle with 199 degrees out of 360. We'll cross multiply. We'll take our 8414 and times that by 360. And then we can divide that by our 199. So the area of our circle is obviously going to be larger than the sector, so it's 152. It's almost twice as big because in the circle it's almost half a circle. Find the area of the shaded region. Well, that's the sector area over the circle area, which is pi r squared. The angle is 110 over 360. The sector area pi times 12.8 squared is is 514.02. We'll cross multiply, times that by 110. So the sector area is going to be 56,619.04 over 360. So we'll divide that by 360, and our sector area is going to be 157.28 millimeters squared. The units were in millimeters. We're doing area, so it's millimeters squared. Last question. We have this full square. We have circles inside this box. All in here is our shaded region that we want to figure out. How much space do these circles not take up? That's the shaded region we're trying to identify. So what we're going to do is take the square and subtract 16 circles from it. Now, if each side is 32, we're going to take 32 and divide it by 4, which is 8. So the diameter of each one of these is 8. So the radius of each circle is 4. So the area of each circle is pi r squared. So we call it 16 pi. If we're going to have 16 of these circles, then it's 16 times 16 pi. That would be all the areas. So the area of the square is 32 times 32, length times width, minus 16 times 16 pi. We get 1,024 minus our 16 pi, which is 256. 16 times 16 is 256. Times that by pi. And we're going to get a final answer of 219.75 centimeters squared. That's the area of the shaded region in between all the circles.